Hi everybody. Ooh, good afternoon, evening, whatever's going on. Hi Metalis, welcome. It's 4 p.m. and I thought we should get started with another installment of How to Start Stargazing. I wasn't able to do my regular schedule. I've been a little bit more spotty with my bi-weekly other series on, but I thought I want to do this every month, and I'll get back to Ask an Astronomer probably next week, depending on political climate. Maybe it's something we'll need. I don't know. But I really, I just said hello. But I wanted to say hello. I wanted to do another one of these because it's about to be November, and I think that it's pretty fun to teach people about, some of the November stars and that. And I also I wanted to spend some time talking about the moon, mostly because last night, which was Halloween here in America, was a full moon. And I was looking at it. I was outside. I spent Halloween sitting outside by a fire and looking out at the moon and the stars and stuff. And I was realizing that, I have friends who have not ever seen me do these stargazing things, and I wanted to give some people a chance to learn about, some stuff that I have taught and I think is pretty basic about the moon that generally most people don't really think that much about. So let's start the way we always do. Here we are back in Stellarium, looking out, around what time it is right now. Actually, I guess if I do right now, it's here, and I could go there. So this is exactly right now. I don't know why. There we go. Here's exactly now. So it's still light out where I live. The sun is setting, though. You got to hear it setting in the southwest. And now remember, the sun sets here in the southwest as opposed to directly in the west-west because we're getting into the winter. We're in late fall right now. And so remember, if we kind of zoom out a little bit, you wouldn't be able to do this without having a 1990s era fisheye lens, But imagine you could see both southeast and southwest. The sun will rise and set farther down towards the horizon in the winter because the Earth is kind of pointing away from the sun in the northern hemisphere, which is why we have winter where the light's coming at a higher angle, or like a lower angle to us, which spreads the light out and makes it a little bit less intense. That and shorter days means it gets colder. But that's why the sun's going to have a path over here, so that at noon, like if we were to go back to noon, like if I scan back in time to noon, here's noon, right? Here, and you can see I'm looking down here where it says 11:58. If I zoom back in, this is not directly overhead, right? Directly overhead, right? If I zoom out, directly overhead would be right, directly overhead, but the sun doesn't go directly overhead when you're this far into the late fall, early winter. But let's head into sunset, so you can see what I was watching last night as the sunset, and hopefully you've been going out and taking a look if you've had clear nights and looking at the stars. But or if you're watching this in the future on YouTube, maybe at some point in November, maybe you're about to go out. But you should go out. November's a nice time before it gets too cold, although some places in America it's already gotten too cold. Where I live, which as you can see down here is Tucson, today was in the 90s. Actually, I guess it got to a high of 88, so it's getting pretty hot. But anyway, here's right after sunset on a clear, dark night, and wow, lots of fun stuff to see, right? Immediately, there's a couple things that I want to point out that we've been looking at a lot for the last couple months that we're going to, still possible to see, obviously. This is right after sunset. So for me, this is 6:30, so only an hour after sunset. But over here in the southwest, you have some, pretty bright stars that make up some very important summer constellations, including Sagittarius here, which looks like a teapot we've talked about before. You see the little top of the teapot, the handle of the teapot, the spout of the teapot right here. But above it are two very bright objects, one a lot brighter than the other, and this other one is a little bit reddish, just slightly. And these are planets. So we've talked about this in the past. We talked about this last month, for a while. But this is Jupiter and this is Saturn. And you know that you're looking at right because notice they're pointing over here towards the southwest. They follow a line with the sun, this line, I don't know why I'm gesturing on here, that's not going to do anything, but they follow a line that stretches up and across the sky called the ecliptic. And the ecliptic is if you took our solar system, if you imagine there was a line that connected all the, that showed you what the solar system was, which is kind of a plate or a disc, right? That solar system, everything is moving in a disk except for, you know, some of the really far away orbits are kind of at weird inclined planes, but they're all in one plane. That plane is shifted like this. Well, I guess here in the thing, I should watch my view, but that it's, you know, it's in a plane that if you drew a line, that would essentially go sun all the way through this, and it would continue crossing across the sky to two important things, this one and then this thing that's rising on the horizon. But this here is the other thing that you can see right now that's pretty incredible, which is Mars. And Mars is the thing that for the next month or so is going to be the thing to go look at. If you're in the Northern Hemisphere, go outside and look at Mars. It's really beautiful. I was sitting out with a friend last night and she pointed up and she's like, "What's that?" And I was like, "That's Mars." Blew her mind. And you should really take some time to look at it, because as you can see when I sit here, like eventually it fades everything out. This is so much brighter than anything else, right? If I click on it, you can see that its absolute, or its magnitude right here is negative 2.11. It's reduced by a little bit, but it's essentially negative 2.11. So magnitude, the magnitude system, which is the way that astronomers assign brightnesses to stars when they're not doing it in flux units, which I don't want to get into, but that magnitude system, as you get more and more negative or smaller, then more negative, the brighter it is. And so like, if I click on something like, let's click on a fairly bright star right here, this one right here. This is 0.75, that's Altair, pretty bright. You know, this is Deneb 1.25. Vega here is 0. It's defined essentially as 0 in the system here. So Vega is 0, and so this you know, planet here is negative 2.11. And that doesn't mean it's like a little bit smaller. It means it's a couple orders of magnitude brighter than Vega. So it's very, very bright, very obvious. Even if you live someplace, like I was talking to someone who lives in Chicago and they were like, "I can't go stargazing, I live in a city." It's not hard to go out and see Mars. You can just go out and see Mars as long as there's no buildings blocking the way or clouds blocking the way. It's pretty obvious. And the way you're gonna wanna do that is looking towards the east, you know, and southeast before this thing happens that's gonna happen in a second. So as we keep going, notice something is starting to rise over here. And this is the thing we'll be talking about for most of the night, which is the moon. So we'll talk about that a little bit later. But before we get into that, let's see if we can practice what we've been doing the last couple times, where we bring up our sky map. So I go to skymaps.com, I download this month's sky map, which is a November sky map. It shows how the night sky looks early November around 8 p.m. So I wait until 8 p.m. Here's us waiting until 8 p.m. Are you ready? Da 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 da. And da 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 da. Here. So here's about 8 p.m. And I go, okay. And then I go outside at night and I go, all right, well now I've got, oh, the meridian line is on. I don't know how, there we go. Meridian does not need to be on. The meridian is a line that connects north and south. It just, you take the south and you draw it all straight up in the air to north. That's the meridian. Not important for what we're doing now. Like if you took a line and just drew it here to here, straight across this. You're not seeing that? What am I talking about? If you took a line and drew it from here all the way up to here, that's the meridian line. Not so important. So here's our sky map. We remember when we've got it, we've printed it out, or we brought it up on an iPad or something and turned the brightness down. Or, you know, north is generally up here, and that would be as if you were holding it so that north were, you could read the word north right. Then you'd be essentially looking north. If you were looking north and holding it where north, then it would work that way. Right? In this case, you'd be holding it, if you were holding it this way, you'd be wanting to look south, because you'd be looking and having the word south here, but if, you know, like easy to read, or west or east, right? You turn it so that the direction you're looking is on the bottom here. That's how you use a sky map again. Now that I've confused everyone watching. You turn it so that the direction you're looking at is the direction that's on the bottom of the sky map right here. And so like we were just doing, we were looking south here. So if you're looking south, Mars was up here, as I said, over towards the southeast. And if we go and look at that times, let's turn off the sky map again. If we go and say, all right, we're looking south and then kind of southeast a little bit, there it is, right up here. Boom, there's Mars, right? And so it's exactly where it says it is. It's not exactly south. What's exactly south? What are these two stars? Well, let's go back to our sky map. And let's look directly, you know, on the sky map where it says, whoops, that's not what I wanted to do. This is what I wanted to do. I clicked on a link and it took me to the link. These two stars might be Alnair and Grus. You know, they might be these bright stars right at the bottom here. And if I were to click on this star right there, it says it's Alnair in Grus, right? Pretty cool. you could just use this. What's this bright star up here? Well, I say, okay, well, I've got these two stars that are pretty bright next to each other. I know this one's Alnair. Like, if I go over this one and up diagonally, what's that star right there? I mean, I clicked on it, but like, you know, if you go over and up, you see that it's on this one. It's pretty bright. It's a brighter, bigger circle. It's Fomohot. And I know I clicked on it, you know, accidentally beforehand, but it's Fomohot, right? Pretty straightforward in Pisces austrinus, the, you know, southern fish. But this is kind of how you do this, right? Now, to see stars of this brightness, I guess I should turn off the thing to show you what I was just saying, which is that, you know, this star right here, as we were just saying, right, is Alnair, and then the star up here is Fomohot, right? But like this, to see some of these really bright stars, you're going to need to like be in a pretty dark place. If you're not in as dark of a place, it's not going to be as easy to see some of these very faint stars. I said bright stars, but some of these fainter stars compared with the big, really bright stars, which we've talked about a bunch. And those are the stars that, if we bring back up the sky map, nope, I want to bring the sky map up here. Whoops. Are the stars that are right over here in the summer triangle, you know, of Altair, Vega, and Deneb, which I just showed you a little bit earlier. But those stars are now not directly overhead. Last month, they were directly overhead at this time, but they're kind of shifting. And next month, they'll be over here near the horizon at 8 p.m. This is what happens as you move around the sun, is that the stars that you thought, you know, were directly overhead at a given time kind of move a little bit at the same time, because you're now seeing them from a different perspective as the Earth moves around the sun. But right now, what's directly overhead is the great square of Pegasus. So let's see if we can find that. Let's see if we can find any of the things we've looked at the last couple months. Like, let's see if we can find the summer triangle. Let's see if we can find the great square of Pegasus. So I take my sky map and I put it down. And then I go, all right, well, we're looking up. So we're going to look directly overhead. Okay. We're going to look for our summer triangle. Now, it's a little bit hard. I'm going to kind of zoom out a little bit so that I can see. But now I see the summer triangle. Here we are. Boom, 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 right? And so we've done this a bunch. We know that this one right here is Altair, and then this one right here is Vega, and this one right here is Deneb. And you might be saying, how do you know that? Well, first I'm an astronomer, but I know that in this triangle, the pointy part is always going to be Altair, right? Then the big problem is, okay, well, which one is Vega and which one is Deneb? Well, in this case, I know that Deneb is part of Cygnus' Swan, and the Swan swims across the Milky Way, so it's the one that's in the Milky Way, first off. You can see the Milky Way, just very hazy, faint. I mean, if I look on my monitor here showing what's going, I can see it. But you can also see the other stars that make up the wings of Deneb, right? And if I turn on my constellation lines, you can see that there they are, right? Flies across, and you can see down here the eagle that Altair is part of, right? Over here, you see Vega is part of this group of stars that, like, you can kind of see this little pouch or this little group of 4 stars that make up the rest of the stringed lyre, which is not really that great. If I were to go and change my, so let's turn this off and let's go change my sky and viewing options to Star Lore Western HA Ray, you can see that his drawing actually kind of includes the, you know, the other stars and the stringed instrument there, but kind of keeps some of the other ones very similar. How you connect the dots is entirely up to you. I will say that every time we do one of these. So we found that. We know we're looking, okay, west, so it's not exactly overhead. And exactly overhead, hopefully, is the great square of Pegasus. And so we're looking, you know, for it. We're seeing some other stuff that maybe we're familiar with, right? Like, it's a little hard to just look up directly at it. Let's see if there's a way in our sky map that we can point towards the great square of Pegasus. So I bring the sky map back up, and let's look. Well, we know we've got these, you know, we know where Deneb and Vega and Altair are, and so we know we could kind of point our way that way. We know that it's maybe a little southish of, but it's a little hard. Maybe Mars might help us. Maybe we can look, essentially, if we're looking from the horizon up to Mars, if we go a little bit farther, we'll see that the 2 stars in the, you know, 3 of the stars in Pegasus here kind of point towards Mars. So let's do that. Let's point there. Again, this is how I actually do this. I go outside with a sky map and I look and say, all right, well, these 2 stars should kind of point towards it. So turn the sky map back off. Let's see if we can find Mars again. So remember, Mars, we're looking south, east. So here's Mars right there. So we look up above it and we see, can we see stars that are kind of pointing towards it that are making our square? And if we do that, we can see that directly above it are the stars, in fact. So turning on the lines again, you can see that we've got Pegasus's wing here, because you can see Pegasus above, and Andromeda over here, right? But this little square right there is in fact the square. And it looks a little bit smaller than you expect because I've kind of zoomed in or zoomed out, but yeah, there you go, right? And then also, this is a really good time. A couple months ago I talked about this, but this is like a pretty good time now that it's directly above you. You don't have to like look on the horizon for you to go out and look for Andromeda and the Andromeda Galaxy. And you see that it kind of popped up over here. But if you know where Mars is, you can go and look and see where, you know, like where is the Pegasus and the left star in this situation. One of the stars, this star is known as, what's it known as? It's Alpha Andromeda, Delta Pegasus. You know, because it's part of two constellations at the same time, essentially. But if you look down, you trace Andromeda, her head, right down here, her body. But these two stars down here just point directly up Andromeda. The problem with looking for Andromeda right now specifically is you only have a limited window of time. This thing is really bright. The moon, when it's full, you get like a full shadow from it. And that's kind of a pain in the butt to have this big full shadow from the moon, because it means that anything else you want to see, any faint things, you can't see. Like right now, it's probably pretty tough to find the Pleiades, which are right next to it. You know, the Pleiades, this group of stars right here, which we'll talk about in a second, they're pretty tough because they're right next to this incredibly bright thing. It's like a mirror of the sun. But if you wait, right after sunset, before the moon rises, like here we are, I've got it at, you know, I'm tracking this at 6:27 here. So 6:27, the moon is just set. Maybe you're thinking about dinner. You can walk outside, and if it's not, you know, might not be dark enough, you might have to wait just a little tiny bit. But, you know, maybe you live in a place where there's buildings and something that you know, gets in front of the moon. But there's like a short amount of time, around 6:30, where you can go out and it's dark enough that you can go say, here is Mars, looking above Mars and looking down and finding the Andromeda Galaxy, right? This is a great usage of your sky map here. So if you turn the sky map on, you can see that the sky map allows you to find Andromeda. It's located and labeled as, oh golly, I need to move this so that I'm not continually clicking on the sky map thing. But like these, you know, the Pegasus here, the stars come down here and you can see M31. And when a star or constellation is right overhead, that's like the best time to see it because you don't have as much air, we call air mass, between you and the object, which kind of reduces the brightness of it, makes it more turbulent, makes it more blurry. Notice on my sky map also, the moon isn't here. Mars is, but the moon isn't. The thing is that Mars, Saturn, Jupiter, they're not going to move appreciably over the month. They'll be with respect to the same stars in the same constellations they're about. They're not going to move a lot. The moon is going to move a lot, and we'll talk about that a little bit later when we get into the bulk of what we're going to talk about today. But the moon is pretty, you know, so they don't put it here. They will over on the right here show near the Pleiades, near Aldebaran, near Castor, near Pollux, and that like matters because as, you know, the moon goes on, it will be moving in the sky towards other stars that like that are pretty bright, that are not even listed on this sky map at all. Right now, it is, you know, it's the first, but tomorrow will be moon near the Pleiades, so the Pleiades are right over. Gosh, why are the Pleiades not even listed on here? I guess they're listed because there's the Hyades, there's the Pleiades right here. So excuse me, they are listed here, but the moon's essentially right around here, and it'll be a little closer to tomorrow, and then it'll continue moving on its way over the course of the night. We'll talk about that a little bit later. What else can we look at tonight? We found Fomohot, which is a pretty classic star. If I go down here, you can say that Fomohot is listed as the brightest star in Pisces Astrinus. It means the fish's mouth. It's 25 light years away, right? So 25 times. I saw that over here. If you're wondering how I just discovered that, that's what's cool about this star map, is that it just pretty easily shows like important information on the backside, which is why it's good to just print this out. It's okay, Metalis. I appreciate you watching and doing homework. Hopefully this is, you know, not too distracting. What else can we look for? Maybe we'll do something fun. We'll look for Hercules. Because Hercules is down near the horizon right now, which makes it a kind of fun thing to look for. So let's see if we can find Hercules right now. Hercules is not a particularly bright constellation, but why not? Let's look for it. I'm gonna turn the internet back. So let's go back and say, all right, how do we find Hercules? What are we doing? Hey, what's this going on there? How do we find Hercules? Well, we go north, west. So let's find which way north is by looking for the North Star, looking for Cassiopeia maybe. Maybe can we find the Big Dipper? It's a little low on the horizon, which is going to make it hard. We know which way kind of southeast is, which is Mars. So let's look on the opposite part of the sky from where Mars is in the horizon. Like we look at Mars and then turn around 180. That might be the way to go. That'll show us northwest. And what we're going to look for, is we're going to look for Maybe we can find, maybe what we'll do is we'll take the summer triangle and go between Deneb and Vega down there. We'll just go down from Deneb through Vega, and that'll get us to Hercules. That's the good way to do it. We'll get in the right part of the sky first. So let's turn off the internet here. So we've got Mars. So we're looking at Mars. Let's turn 180 degrees. Beep, 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 beep. Which, you know, we're looking essentially east, southeast. So we're looking north, northwest here. And so now we're going to look up for the summer triangle. Here's the summer triangle again. These two stars are going to point down. And so here is essentially where Hercules is. And let's go a little bit farther in time to where it actually says 8 p.m. And so the question is, where is Hercules? Well, Hercules is a little tough to find, right? Because it's not super bright. It's these stars here. And in fact, if I go back, I don't need to go this far forward. But if I go back, we can see maybe some of them. But essentially, Hercules' body is kind of this big, large area here. And Hercules is, you know, like if we turn on the constellation lines, you can start seeing it right here. This is Hercules. So I'm going to turn them off again. And you can see that Hercules, this is Hercules' head. And then the body comes over here. Right? So it's directly, as we said, directly south, going from here right through here to this. If we zoom in a little bit, it might make it a little bit easier to see. The club kind of comes up here, and the arm comes down there, and these are the legs. But notice that, like, if I turn it off, it doesn't just, like, pop out. The head does, but the rest of the stars don't really differentiate themselves as much, right? It's not the brightest constellation of all. It's not the easiest to find, but it's a nice one to look for if you are wanting to do an advanced degree in stargazing for an evening, to go, like, looking for some things like this. And if you've got a pair of binoculars, or if you've got a nice telescope, you can look for M13. Oh, look, we've got a satellite here. If we click on the satellite, we can see this is Starlink 1437. So this is one of the Starlink satellites, which it's the worst. These Starlink satellites are pretty lame. Anyway, especially because if you're observing right now and this thing just crosses through, it just destroys your entire observation, which is not that good. But like, if we zoom in a little bit more with our like fancy telescope here, and we look up, let's look up M13. So in the head right now of, you know, you can see there's this thing here. And if I zoom in, this right here is M13. It's the Great Star Cluster in Hercules. It's something that with a, you know, nice telescope, you can find, you know, pretty easily, providing you know where the head is, looking between these two, right? And look, it's a star cluster. It's a globular star cluster. These stars are, you know, incredibly, incredibly old compared with other stars like the Pleiades we talked about earlier. Lame, like in functionality. Oh, Starlink is a thing that was designed to like deliver like internet for people, but it's incredibly expensive, so it's not going to be any cheaper. Also, they launch a whole bunch of them, and they have like made a direct impact on astronomy observations. And that like there are pictures where like an entire fleet of Starlink satellites just like destroys your astronomy observation. And astronomy observations are not a thing where you take like you know, one exposure and you're like, oh, I got trails in there. If you take a 45-minute exposure and you get trails in, you have to throw out the entire exposure, and like that's bad. That means you've wasted 45 minutes of time that is really, really valuable on a telescope. So I don't see the upside of a Starlink. I think that, you know, trying to provide not super fast internet that costs a whole bunch of money is not a great upside. Anyway, and see, M13 here is also listed as you know, like it's listed. If I go back to my sky map, it's listed over here. So if I go to M13 and Hercules, easily seen with binoculars, best globular in the northern skies, discovered by Halley in 1714. It's 23,000 light years. So you're seeing it pretty far away, right? 23,000 light years. You're seeing it as it was 23,000 years ago, which is why it's kind of fun. I have a pair of binoculars. I'm gonna go grab them. Maybe tonight I'll go out with these binoculars. In fact, 100%. That's what I'm going to do tonight. I'm going to go out with these binoculars. These are Celestron Cometron binoculars. You know, they're just a kind of classic pair of binoculars here. Lost one of the eye caps at the moment. But with binoculars, you can sit down in a chair. Don't try and stand up and use them. You sit in your chair. You maybe get yourself in a position where you can, you know, rest your hands here because you want pretty good... you want to have like a pretty good way to stabilize these things. But then there are two things. Most people don't recognize how to use binoculars. There are two things in binoculars that allow you to work. One is on the top of binoculars, there's one set of focal thing. There's this right here. Here, let me make my life a little easier. I'm so big. There's this thing which helps to focus, right? Oh man, it's so funny that if I turn off the sky map really quickly, that because anytime I get close to the light, there's this thing right here that turning it will focus, but then also on one of the eyepieces, in this case it's my right eyepiece, there's another focal thing. And so what you do is you do the gross focus, and then if your eyes have different focuses, you just change one of them. So you focus for your left eye essentially with the both of them. So if I look down the hall, and you wouldn't want to use the hallway because you want to do something that's really far away. So like I might, after this, go outside and look down the street as far as I can. There's a mountain on the other side, like that's down the way from where I live. Like you can see this mountain. And I'll look and then focus with the top first, and I'll just make sure the left eye is as focused as I can get it. So if I just do this in my house, which is again a terrible idea because there's the thing that I'm focusing on is not that far away. And then the right eye is still in focus. I'll focus the right eye by just closing my left eye, and now both sides are focused. And the other thing is that you have this, which changes the focal the distance between your eyes. So you might have to do this a little bit and twisting it until you get exactly the spot. But you want to get it and twist these both until you get a pretty good focus with both eyes. And then you just park yourself outside, sit this on your stomach or whatever, and try and find the thing by looking for where the stars are. Maybe you start with the moon. That's a good one to start with. If you've not looked at the moon through a pair of binoculars, it's pretty wicked. But like looking to see if you can find Andromeda or if you can find the cluster here, pretty classic things. Get your sky map out. Again, maybe it's a graduate degree, but I recommend binoculars before I recommend buying a full-on telescope, because binoculars are much cheaper and they're much easier to set up, and they're much easier to store and travel with. Like you can throw these in a bag. When I go camping and stuff, like this is much easier to travel with than an entire telescope that you have to set up. So anyway, shrinking myself back down because we got to talk about the moon at some point. That's a kind of classic deep sky object that you might want to look at is in the head of Hercules here, which zooming out a little bit you can see is westish. And the way to find it is looking for the Great Square or the Great Summer Triangle here, and looking straight down from Deneb up here through Vega will get you kind of in the ballpark down here, and looking for these 4 stars that are the head, and recognizing that kind of weird keystone shape is pretty important. So I keep talking about it. Let's talk about the moon. So let's let the moon rise. The moon was full yesterday. And it was the second full moon in a month, which we've given a name. Anybody know the name of the second full moon in a month? It is also a song. It is a blue moon, a blue moon. And so if we go here and kind of focus, you can see the moon. Pretty classic moon. Notice it's not full anymore because it's today. But if I were to go back one day, so like we just take the time and go, all right, let's go back in time by one day. Boom. First off, it's up a little bit higher in a different spot, and it's full, right? Full moon. But then if I zoom back out, go to today, it's down over here, and it is not full. It's starting to wane. You're seeing some more shadow over here. So what's going on with the moon? Well, first off, the moon is Earth's natural satellite. If you look at our distance here, does it tell you the distance between the Earth and the moon? Distance from us is 402,000 kilometers, right? It's 8 light seconds away. So like the light you're seeing from the moon is the moon as it was 8 seconds ago. It's about 30 Earths from, like if you take the Earth's diameter and like line it up 30 times, that's how far it takes to get to the moon. So it's quite a ways away. It's about a fourth the size of the Earth, so like a quarter of the Earth. So if you took 4 moons and lined them up, that would be the Earth. So it's not super big, but it's a nice size. We think that it probably came from some sort of collision that happened early in the Earth's history where Mars-sized rock may have crashed into the Earth and knocked it off into space. And we've been there, so we can actually go and we've stood on the moon and brought moon rocks back and seen that the moon rocks kind of are similar to the rocks that are in the surface layers of the Earth. So it kind of lends some credence to that. The moon orbits the Earth as you might know, and it orbits the Earth in about 27 days. So it takes 27 days for the moon to go entirely around the Earth. And that 27 days might seem similar to a certain period of time on our planet that we call a month. And that's not a coincidence. A month is how long it takes. Like a month was named after the moon, right? It was a thing where it's not exact. The moon doesn't go around the sun, or around the Earth, like 12 exact times in the time it takes the Earth go around the sun. It's, it doesn't take exactly 27 days. It's like 27 days and like a third of a day. But there, generally people, when they were watching the moon, they noticed that its patterns changed in that it would repeat the same pattern every 27 days. And we would get to the same spot in the sky every 365 days. And you could kind of divide those two and go, well, there's these 12 kind of periods of the moon, which we called the months. And like it, for a while it was 10 months. Like, it's a complicated thing with calendars. I don't want to get into calendars, but the patterns that people notice, you may not think about very often now. People don't really think much about the moon's patterns, and I wanted to talk about them today because the moon's patterns happen every month, and you can start to understand when it'll rise, when it'll set, all these things just by thinking about the moon's pattern. So the first thing, as I said, is the moon goes around the Earth, right? 27 days. One of the other things is the moon is what we call tidally locked, meaning one side of the moon always faces towards the Earth. The same side always faces towards the Earth. It's almost exactly, it does do a little bit of wobbling, but generally one side faces towards the Earth, which is why every time you see pictures of the moon, it looks like this. I'm going to pause it, or else it's going to, I guess it's not even moving right now, is it? Oh, it is. I'm going to pause it. There we go. I don't have to worry. It looks like this. So you're seeing this where you've got, these dark spots and craters and the rabbit on the moon, right? You can see the ears of the rabbit. People say there's a man on the moon. I've never been able to see the man on the moon. I guess maybe there's eyes here, you could say. But like, this is the side that faces the Earth. And the problem is that Pink Floyd at one point made an album called The Dark Side of the Moon. And right now with the full moon, there is a side that is dark, right? But there's always a dark side of the moon. There's always a dark side of the Earth. It's not the same side as the thing. This week, the moon was in the news because astronomers published a result that said that they discovered in some of the craters here on the bright side surface, this telescope SOFIA, this airborne plane-based telescope, which is a very cool thing, discovered evidence that there's water in some of these craters in the surface like particles of the moon. It's like not a lot of water. It's a lot less than the water if you like took the water all that was in the Sahara Desert, and like it's like 1/100th of that. So not a lot of water, but just enough that it tells us about the history of water in our solar system, and maybe there's other sources of water on the moon as well, which is pretty cool. But I kept reading in these articles like, oh, they found it on the bright side of the moon, and the thing is that like this side of the moon is bright right now, but it is a thing where like this side of the moon will also be in the dark. That's what we call a new moon. And this side of the moon will also be half bright. And this is the thing about the moon phases. Is the moon phases have one side being dark and one side being bright. And we're just seeing the dark side, like the shadow side, in more and more detail. So I'll go into that a little bit in a second. So one of the things that like right now the moon is in this part of the sky, right? As I said, we talked about, it's over in the, the east. It rose over in the east. And at 8 p.m., this is where it'll be in the Northern Hemisphere right now. But let's look at something that I was just showing you. So I'm going to go back and open up the date and time. I'm going to bounce time backwards. So we're going to look at 8 p.m. 8 p.m., so let's go back. 8 p.m. last night, the night before, 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 the night before. And the thing is that it's not like the moon is just slowly moving. It's not staying in that, like the Earth is rotating, so it, rises and sets as well. But like now you're seeing that every night the moon is, as we go forward in time, if you go back at the same time, like look at it with compared to Mars, right? So like, and the stars, like look at it as it gets closer to Mars every night, the same time. Look at how much it's really motoring. This is because it's moving around the Earth. It has to get around the whole Earth in 27 days, right? So it goes 1/27th of a circle every time, every night, right? So 8 p.m. tonight, tomorrow night, 8 p.m. there. In fact, it's kind of funny that the sky map says that it's close to the Pleiades on the 2nd, because it looks like it's pretty close to the Pleiades tonight, right? Tomorrow it's a little farther from the Pleiades. The next night here, And the next night here, and here, and here, and here, and here. And you're not even seeing it right now, right? You have to wait longer for it to rise. So let's look at it on the 8th, right? So this is in a week. In a week, notice it's like 8, 9 p.m. Moon hasn't risen. 10 p.m. Moon still hasn't risen. Where's the damn moon? 11, 12. Where's the moon? There's the moon. It's almost 1 in the morning and the moon is starting to rise. Wow. So that means that if you brought these things and you want to go look at some stars and some deep skies, just wait a week. And the moon will essentially, you'll be able to go out at 8 or 9 and see the same sorts of things that without the moon being super bright. The other thing that's happening with the moon, besides that it's taking a lot longer for it to rise because it's continuing to move, away from the way, the same spot in the sky at the same time of night. So let's go to, 2 in the morning on the 9th, right? So now it's the 9th of November. So this is more than a week away. If we zoom in here, what? Notice this. It's not a full moon anymore. Isn't that interesting? This right here you're seeing is the dark side of the moon in this case. And this is the bright side, but you're still seeing the same spot. Like if you could still see, if we had like the brightness turned up a little bit, you'd be able to see the rabbit on the moon and stuff. Like this is the exact same thing as you saw, you would see last night and tonight. It's just you're only seeing it, you're seeing the shadows here. Why? Well, the moon has moved in a week a quarter of the way essentially around the Earth. A quarter of the way in its travel around the Earth. So here's the thing. Let's bring this back up. Let's make my hand. I'm going to do something with my flashlight here. All right, so I've got my flashlight on, and I've got my hand here. It's a little hard because I've got my, because if I shine something really bright, it just assumes that that's, but like, if you look at my face right now, look at that. So if I go a quarter of the way around, this is like full face Kevin, right? If I go a quarter of the way, look at this side right here, and if I move it, you can see this side right here is lit up. You know it because it's showing the crazy, optical effect, right? This is the type of moon you're seeing in a week, right? And in 2 weeks, the sun will be over here, and this will be entirely dark. And in 3 weeks, this will be the side. And right now, tonight, last night, you're seeing full moon. So essentially what you're seeing is, you're seeing as the moon moves around at the same time of night, when you go look out, because it's night, so we're still pointing away from the sun, the Earth is, the same time of night, the moon's moved in another spot around the Earth. So the sun is pointing at it from a different angle. So let's just show that in a different way. Whoop, make myself real tiny there. Let's just show that in a different way. Let's actually show that with Space Engine. So I'm going to turn Solarium off. We go to some stars here. And so now if I zoom out, here is the moon. It's decided to be really low resolution right now because I zoomed out too quickly. But this is the moon. And we've actually got to flip it a little bit to show what the moon looks like from the Earth. So the moon looks like this from the Earth. So you can see the rabbit again, right? But if we zoom back out, we should eventually pass by the Earth. You should hopefully see the Earth in just a second. Oh, there it is. So there's the Earth, right? So this should be, yeah, this is actually, let's current time. Boom. So here, there we are. There's the Earth and there's the moon. So, there we are. Earth, moon, and the moon is essentially almost full from our perspective, right? From the Earth's perspective, right? That's why I was able to just like fly away and get the moon, Earth right there. Pretty cool. Where's the sun? Well, the sun, because we see that the moon is lit up like this side, the sun should be right there. Boom. And you can see from the point of view of the moon right now, we have a new Earth. The Earth looks real dark, and you see just like a little crescent of Earth right around the edge right there. Pretty cool. But let's fast forward to the 9th. Okay, so I'm going to fly up here, and I'm going to turn this line on so you can see the point of view, and let's change the angle a little bit. There we go. All right, so here's the moon. There's the Earth. Let's zoom out a little bit more, and let's make time go to, whoops. let's go to the 9th of November, which I was just talking about, right? Boom. So we move to the 9th of November, and look what we've got. Earth here, the moon, instead of being over in this part right there, the moon is over here. So again, one side is lit up. One side is fully lit up, right? But notice it's not the side you would normally see. The side that Earth sees is here. And look at this. You're just seeing the side that's not lit up because the sun's over there, and you're seeing over here. Let's turn off these lines, they're distracting. You're seeing just the side that's lit up versus the side. I will, Metalis, talk about eclipses. I'll actually show off a pretty cool eclipse thing. So from the moon's perspective, the Earth is also a half Earth, right? And from the Earth's perspective, the moon looks like this. And so if I go and bring this up, you can still see if I turn on, gosh, you go so fast here. If I turn on my brightness, you can still see the moon, or the rabbit. It's just generally, from the Earth, you can't really see very well the dark side of the moon, dark part of the moon, you know. But that's what you're seeing here. So if I go back to Stellarium, here it is, right? And like, it doesn't look exactly like I've lined up because we're at a different angle on the Earth than we were. But like, you know, this is what we call right here a last quarter moon, right? And so the moon goes full, right? I think it's that way, right? I'm pretty sure that it goes first quarter, new first quarter, yeah, full moon, last quarter, new moon. And the last quarter moon, the left side here is pointing towards the side that's pointing, you know, like towards the sun. Like this left side is, the side that's pointing towards where it rose. That is the side that is saying it's last quarter, that's lit, right? Okay. But if we go another week, let's keep going. So same time of night, boom, it's down a little farther, boom. Actually, here's something interesting. If we were at a true last quarter moon, which I think is maybe the 8th here, where it's exactly half. Yeah, there's our true last quarter moon, essentially, which is on the 8th. What time does it rise? Well, it doesn't rise at 2 because it's already risen. 1. It rises at around midnight. So a full moon, because when the full moon is there, the sun is pointing directly at it, which means that you're seeing the sun entirely shining on it. So the sun's opposite it. So that when the sun sets, the full moon rises. So last night, the full moon rose right around sunset, right around 6 p.m. essentially. A last quarter moon, where it's now a quarter of the way around, you're seeing it rising at around midnight. And you can see here, it's because right now, where is the sun? Well, the sun is down below us. It's, you know, at noon on the other side of the world. So right now, midnight means that the sun, whoa, that's too zoomed out. Midnight means that the sun is on the other side of the Earth. It's noon for people in, you know, Asia, China, Africa. Like it's noon around there. And so they have the sun directly overhead, which means that we don't. And so the sun is pointing at one side of the moon, and you can imagine, right? Like imagine the moon floating out in space, and the sun is over here shining on the other side of the Earth, and so it's rising right at midnight. Pretty cool. And so if we go another 7 days, 1, 2, 3, 4, 5, 6, 7, we're like, where's the dang moon? Well, let's see. We go boom, 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 4, 5. Oh, here it is. No, that's not it. What is that? What are these things? Oh, this is Mercury and Venus. Whoa. Oh my gosh. That's not what I wanted. Where is the moon? Well, it's hard to see because we're now 7 days away. It should be a new moon. There's the moon. So the moon is right here. Notice, not lit up at all. Just a little crescent here. So this is November 15th. We have a new moon, which means if we go back to Space Engine, so if I turn off Stellarium here, and go back to Space Engine, let's go to the 15th. Oh, no. Whoa, oh. All right, so there's the Earth. Here's the moon. Let's go look at the moon from the Earth. We're noontime, you know, like we look. Oh, bright sun. Where's the moon? I can see it right there. If we zoom in, there's the moon. So in its orbit around the Earth, it is now essentially between us and the sun. Not exactly us and the sun, but it's fairly close to being between us. It's in some region where we can't see the side that's lit up. Meaning, the dark side of the moon is the side we normally see. You can see the rabbit there, right? There's the rabbit, right over here, which is pretty crazy. That like, do werewolves on the moon become wolves when there's a full Earth? I assume so. I don't think that they're called werewolves or something. I think they might be called something else, Earth wolves. But I think that it must just be that they're triggered by, or they just they're always werewolves because they're always triggered because they're on the moon, which is what's delivering their power. I don't know enough about lycanthropy. But this right here is what we call a new moon, right? So going back to Stellarium, nope, that's the internet. That's not what I want. Going back to Stellarium, the new moon is hard to see because it's the daytime. So if I zoom back out, it's the daytime. The sun has risen here. The moon is really hard to see because it's right. You can only see it because of where it sits in the sky compared with the sun, right? When we were doing, when we were looking at space engine, we were out in space. We didn't have the atmosphere, which is, becoming blue because it's the daytime, right? And so it's hard to see a new moon. The way you see it is you wait a little bit. But if we keep going, so 8 a.m., here's the 16th, the 17th, the 18th, the 19th, 20th. So we're going to go 8 more days from the 15th. So 15 plus 8, 23. Now where's the moon? Well, let's look up in the sky. Or let's keep this going. Because we discovered that a new moon rises around dawn. So maybe this one will rise at around noon. When the sun is really up here, let's look for the moon down over here. Let's actually look for the moon specifically. Has not risen yet. There we are. So it looks like it takes, it's noonish. In this case, it's about 1:30. But noonish, is when this one will rise. If we zoom, boom. It's because we're 1 day ahead. So there, that's good. Zoom back out and let's go. Aha, perfect. This is 1:15 right here. And this is our first quarter moon. There's the rabbit's head. And in this case, where's the sun? Well, which side is pointing towards the sun? There, that side right there. The side that's, lit up. And so this right here rises. So the way full moon rises at 6 p.m. Last quarter moon rises at midnight. New moon rises at 6 a.m., dawn, essentially. And first quarter moon rises at noon, essentially. Those are the 4 phases of the moon. And it goes through that once every 27 days. In the meantime, it's got a motor around, so it's not going to stay in the same part of the sky, which is why a sky map doesn't put it on there, because it just says, I'll probably be over near here, be over near here. But that also means that if you're an astronomer, there are certain times when you want to observe if you're worried about moonlight, and those are times in which the moon is not particularly in the sky, right? Like where it's in the sky during the day, essentially. Like this is a pretty cool time to observe because, it's 1 p.m. Like you don't have to see the moon at all until it sets. So between the hours of 10 p.m., there's the moon on the other side. Between the hours of 10 p.m. And 1, 2, 3, 4, 5, 6, 7, 8 hours, you don't have moon at all. So if you got the end of the night, the moon is set, it's incredibly dark. The moon is very bright if you're out in an incredibly dark sky and it's pretty full. So there was a request to understand eclipses. And let's look at eclipses. We'll go here. So let's open this up. Let's go to here. Let's go to the eclipse here. Boom. So 2017, there was a total solar eclipse that passed across America. I happened to be in Nebraska for it. It was really nice. It was a month before, August of 2017 was a month before I got engaged. My wife was completely assumed that I was about to engage, propose to her, so she had the counter proposal ready. But here we have the moon. It's in a low resolution mode because sometimes Space Engine doesn't want to load the right thing. And behind it, you can see which side is lit up, so you can see which way the sun is probably pointing, right? The sun's probably over here. In fact, there it is. But it's actually lined up pretty well, meaning if I'm here and I turn directly around, there's the sun. It's lined up so well that if we sit here on the moon and we look, we kind of center here. Can you see something pretty interesting up in the corner here of the Earth? Do you know what this is? This is the shadow. I did not propose on that day. I looked at my wife proposed a month later, because I was going to wait. This is a long story. I don't need to talk about that. My wife proposed a month later. She thought I was going to propose and had a thing for a counter proposal, but it didn't end up being necessary. But here is this shadow right here. Now it's funny because right now it has not loaded in the Earth, America, pretty well. But if I zoom in a little bit and fly in, hopefully it loads it in. Apparently it doesn't want to. It just wants to load in. Gosh, that's really bad. Here, let me do this. Let me make life a little easier. So I'm going to bring back Stellarium. And then I'm going to cancel out and continue. And hopefully, nope, I'm going to cancel out. I'm going to exit it. And I'm going to bring it up again because I do not like that it does this. Sometimes it decides I don't want to load the textures. And I need to like ask how you reload the textures. But hopefully, if I turn off Stellarium, once it loads back in, it will have the textures there because you need to see the America part of it. It's kind of important. There we are. Yeah, baby. Okay, so now, please, OBS, tell me. There we go. So, whoa! I was going way too fast. Shouldn't shout. So here we are, looking down at America. You can see, you know, Baja California and Mexico. You see Florida down here. You see California. And you see this big splotch here. And in the splotch, they've actually, you know, whatever cities are down here in Oregon or whatever have like turned lights on. This is the eclipse. And if we go land here, we just go land right on the Earth here. And we look up, it's dark. We're in the middle of the day. Oh gosh, whoops. We're in the middle of the day. And look, right here, center on it, you're seeing that at this exact point, the moon, whose orbit is angled at a weird angle, has actually passed exactly between us and the sun. And if we were to go back in time a little bit, or forward in time a little bit, let's zoom back out a little bit so you can see. You can start to see that the moon continues moving as the sun keeps rising in the sky. And eventually they're not perfectly lined up. But notice something when you see right here. This right here, the sun is pretty close in size to the moon. There's no reason for them to be that close. It's a pretty amazing miracle. But this is one of the cool, awesome miracles of the fact that the moon is at a distance where it's almost exactly the same size in the sky as the sun, is that you get these really great like eclipses like this. If I set the normal time speed and I go back, we can get back in time to see it as it just like really perfectly lines up and makes everything dark. And you get this like incredibly eerie moment where now, looking at it, if we, you know, crank up the brightness, you can see all of the corona of the sun because the moon is blocking the bright disk of the sun. And if you've never seen one of these things, it is super, super eerie. It was very weird to be in Nebraska. Like, it just got dark in the middle of the day. Everyone was just like, what? Like, it was really weird. Even weirder is that when beforehand, the fact that the sun was like a tiny sliver meant that all of the light filtering through tiny pinholes in trees between leaves caused a bunch of little sliver shadows that looked like little crescents. It was really very weird. And it all happens, if we zoom up into space, because of a perfect lineup. You don't get this lineup all the time because they, you have to be really, really well lined up. But if we turn this back to here. But on that day in August, we have this great perfect lineup. And if we watch here, we can watch as the shadow crawls across the Earth. As the Earth rotates, watch that shadow crawl across. You see? So I was in Nebraska, so I saw it around here. Pretty nice. And then it crawled right across, and eventually, boom. And so this was just the shadow of the sun, of the moon, as it crawled across the Earth, right? Pretty cool. If you look back up at the sun, where's the sun? Why am I having such a hard time? You know, you can see, zooming in, centering this, you can see the lineup, which isn't perfect, but pretty incredible, right? Pretty incredible. So in the last couple seconds, I want to talk about lunar eclipses, which are different than solar eclipses, because the lunar eclipse, so if we zoom out, you can see that we've got this lineup where we've got Earth, Moon, hard to see, but the moon kind of like lights up there, Earth, Moon lined up with the sun. If you put the Earth over on the other side, then you'll have a lunar eclipse, which is where the moon enters the shadow of the Earth as opposed to the vice versa. So if I go down here and we look up a lunar eclipse, which is in July of 2018, and you can look up future eclipses. There's going to be another eclipse in America, and if you didn't see the one in 2017, go see that. Solar eclipses are incredible. Lunar eclipses happen a lot more often because the Earth's shadow is really big compared with the moon's shadow. But if we do this, hypothetically, it will load. We now have, where is the Earth? Where is the Earth? Oh, we're on it. That's what's going on. All right, so now let's look for the moon. What's this? That's Mars. Let's look at the moon. All right, so where is the moon? Well, if we zoom in, we see that we really can't see it. Interesting. It's there. It's just we can't see it. Weird. So let's zoom back out. Let's let time go on. Up. We track the moon. Why is it that we can't see the moon at all? Whew. Something is going on in Space Engine that is making it really hard to see the moon. Where is the moon? Oh, okay. All textures have been broken on the moon entirely. So that's bad. Anyway, if Space Engine wasn't completely broken right now, if we were to go and look at, so this is 7/28/2018. So let's do this in Stellarium. So if we go 7/28 and center on the moon, all right. Here's the moon. And if we go and zoom in on it, it's going to do it. It's going to do it. At some point, the moon just enters the shadow of the Earth. Apparently, it's not going to do it in Stellarium either. Well, this is a bummer. Why is Stellarium not simulating this? Space Engine really annoys me. But at a certain point, the moon enters the shadow of the Earth and gets incredibly dark, and then when it hits the perfect shadow, it becomes kind of red because light goes through the atmosphere of the Earth and causes it to be very red. Yeah, I should restart Space Engine now and see what's going on. So I'm going to do that. I'm going to restart Space Engine while I'm looking at this one more time. Gosh, Space Engine, you're killing me, Smalls. I need to like email the guy who makes Space Engine and say, can you make it so that I can reload the textures sometimes? There's the moon. So let's go back and turn off the internet, or turn off Stellarium here. So there's the moon. Now it's finally working. Is this 7/28? It is. So if I make time go on, let's go backwards. Apparently it does not want to do it. Why are we having such a hard time finding? Okay, I know that I did this. Go to that. Please don't have lost your textures. There's the moon. Okay. So now if we center on the moon, nope, not center on the Earth. This is not a super great way of finishing this stream. And now we make time go on. Track the moon. There we are. Boom. Finally, it enters into the shadow of the Earth, and you lose it, right? You can't see it there, even though, you know, if we make time go on, regular rate of speed, flip it. I wish there was better buttons for going forward and backward in time in Space Engine, but, you know. But yeah, you can see the actual entrance of it in the shadow. Like, you can see the shadow of the Earth right there. And so this is a partially eclipsed lunar eclipse. And notice the shadow of the Earth is enormous. It's really big, right? It would be this big giant thing, right? And so if we fly off into space right now, let's turn this off. Whoop. Why did that even happen? Where? Oh my God. There. Fly off into space right now. You're noticing that, like, there's like a weird, only a quarter of the moon is shown right now, because the Earth, you know, from the point of view of here, if we go land on the moon right here and look up at the sun, look at the Earth. The Earth is blocking the sun, right? If we keep going, it rotates across the whole sun, causing this crazy shadow. Okay, and eventually, sun comes back. Pretty cool. So if you lived on the moon, this would be like a total solar eclipse of the sun from the Earth's shadow. That's a lunar eclipse. Happens more often than solar eclipses. Solar eclipses happen quite a bit as well. Okay, it's 5 p.m. I got to think about dinner. But I really had a good time. Thank you for letting me talk to you guys about the moon today. And I'm glad that we got everything working. If you have any other questions or anything, you know, you can ask me. Follow me on Twitter and Instagram. You know, like, I'd love to point you to where I can, on Instagram, you can see the, you know, the stuff about how my wife proposed. If you go back to 2017 in September. But, like, I post other stuff, you know, funny, dumb jokes and things on Twitter. But please, you know, it's wonderful to talk with you. Thank you for coming and following and learning about the moon a little bit. And go look at the stars. Buy some binoculars or borrow some binoculars and go look. I'm going to try tonight, and that'll be fun. Bye, everybody. Bye. Bye. To the solar eclipse thingy. What solar eclipse thingy? Which solar eclipse thingy? Oh, no. I'm going to end the stream after I say goodbye. There we go. Find a video for a solar eclipse.